So now we're going to start our next section, 5.1, which is about antiderivatives and indefinite integration. So our goal in this section will be given a function f of x. We want to find a function capital F of x whose derivative is the function we started off with. So let's look at an example here. Let's say the function we're going to start off with is 3x squared. Then what's a function whose derivative is 3x squared? F of x can be x cubed. The derivative of x cubed is 3x squared. So in this case, we'd say that f, this capital F function, is an antiderivative of the function little f of x. So let me define what antiderivative means in general. So a function, capital F, is an antiderivative of f of little f when I take the derivative of capital F and I get back little f. So that's what an antiderivative is. So I do want to make one note here. So note that unlike derivatives, antiderivatives are not unique. So let me kind of explain that a little bit by going back to our example for the function 3x squared. I could have also said my function capital F is x cubed plus 5. This is also an antiderivative of f of x. The derivative of x cubed plus 5 is also 3x squared. Now you might notice the only thing that differs between our previous function for capital F and this new function is the constant plus 5. And so it turns out that all antiderivatives of f of x equals 3x squared have the form x cubed plus c, where c is a constant. And then this x cubed plus c, we would call this the general solution. So let's look at an example here. Let's find the general solution of the differential equation dy dx is 2. So what we need to do is we need to find, our mission is to find a function whose derivative is 2. Well, I know one such function, y equals 2x. That function has derivative 2, and so from here we can get our general solution. Our general solution would be y equals 2x plus c, where c, again, this capital C represents a constant.